Good morning, good afternoon, everyone. So we are starting this session, this track section on tools for enhancing local energy communities. And I think that local energy communities is a quite hot topic in the as we have seen in the last couple of days, and also by the discussion of this morning. In any case, now we are going to have a discussion with the four the project, European project funded by H2020, but the four project are Merlin, Compile, MuseGrids, and Ielectrics. So the yes, okay. Again. Okay. The speakers will be three at physical attendance. So among the three, there are also me that represent the MuseGrid project, and I moderate this session. But then there is Alessandra Cuneo, which is the coordinator of this of MuseGrid's project. We have Tommy Medvedev of Compile, and we have a virtual attendance of Katerina Valalaki for Merlin project, and Tanguy Chon for Ielectrics, and Pierre-Jacques Lequec for Ielectric. So this is the agenda. Wait. Okay. Okay, this is the agenda of this afternoon. So we start with the presentation of the project with the a short question and answer for each project, and then we have a panel discussion and conclusions and closing remarks. So the order of presentation, we will start with the Muse Grids, and then with Merlin and with Compile, and we will finish with Ielectric. Then the presentation of project should be around 6-7 minutes in order to provide to have more time for the final discussion at the end of the session. Okay, so I leave the floor to Alessandra Cuneo, who is the coordinator of Music project. Please, Alessandra, come here. Just one technical question. We have all the presentation uploaded in the laptop, but if speakers for virtual attendance have their presentation, they can share their screen. Okay.
Okay. So thank you, Gabriele, for the introduction. So I'm Alessandra Cuneo, a project manager in Rina Consulting, and I am the project coordinator of MuseGrids. Just briefly, what MuseGrid talk about is a project that started in November 2018. It's 4-year project. It's coordinated by Rina Consulting and involve 18 partners. Some of them also from international cooperation, because we have a partner from India and a partner from Israel that will contribute to the activities. And the main aim of MuseGrids is to demonstrate a set of technological and non-technological solutions that have the aim to having local energy independency in this to demo site via the promotion of smart energy systems. So actually the project aimed to demonstrate how the interconnection of different energy networks, so the electricity network, the mobility sector, the water network, the heating network, if we are able to integrate them and enhance their synergy, we are able to, let's say, creating a local energy independency also towards the creation of energy communities. The project is based on 4 main pillars. The first one are related to tools for energy community, and I will show you later one of them. So the first one is related to the optimization of the energy management system in a multi-energy point of view. So including in the demand side management the different vectors that we consider in the smart energy system. The second pillar is related to the multi-energy planning tool, which I will present later, which is the topic of my presentation. The third pillar is related to the demonstration and replication. Within the project, we involved two different energy communities, which are very complementary each other. The first one is a demo site that is based in Merlin in Belgium, which is really focused on electricity aspect and increase the power quality of the grid through the integration of power to heat technology, electrical vehicle, and batteries. And the second one is a demo site in Italy, in Osimo, which is managed by a multi-utility, where we are going to demonstrate the interconnection of the district heating network together with the electricity network, the water network, and of course, them are, thanks to the cogeneration plan, also are related to the gas network. And then we have 4 different virtual demo sites, 2 in Spain, 1 in India, and 1 in Israel, where to demonstrate through simulation the potential of MuseGrid's project. And the fourth pillar is related to the creation of an energy community, which is an important aspect of the project. It's important in this system, the engagement of the end users. So the fourth pillar is strictly related to that. Going directly on the tool that I would like to present today is related to a tool for planning multi-energy system that is, let's say, related mainly to the municipalities, so to a tool that could facilitate the municipality to have somehow a positive attitude towards the energy system modeling, and that should help them to consider and evaluate different energy system scenario that, let's say, could facilitate the development of future renewable energy strategies in their municipality. And of course, all of this is related and is considered an holistic sector integrated approach. So going to a brief discussion of the tool. So the tool is... Okay. The tool is composed by the mapping part, so the mapping of the demand and the mapping of the sources that are locally in the municipality. It's an online tool, so you can directly, let's say, mapping your resource and your demand based on open database. And this mapping, together with some other inputs related to the municipality itself, will be the starting point for the scenario analysis. Okay, then, okay. The previous one? Okay, perfect. So the tool has been structured in an Excel file to be user-friendly for the municipality, so to have very simple inputs to be included and a easier management of the tool itself. It's composed by different sections, so they have to, let's say, include the mapping, the demands, which are the supply, the storage, and then through the tool, different scenarios can be set by the user of the tool, so by the manager of the municipality, so to, let's say, evaluate if we increase the electrical vehicle or if we include more PV or whatever, what happened to the energy system. So it's a real tool for the municipality for short-term planning. And it's important, the last point that I would like to highlight is that such tool has been created with the inputs from the municipality to address their needs, their constraints, and what they would like to have that could be useful for them for planning future energy system scenario. Thank you.
Okay, thank you, Alessandra. I don't know if there are any questions from the audience or from people connected in the chat. Okay. Okay, I cannot see anyone. So I asked Caterina Valalaki to present Merlon project. And so, yes, if you want to share your own screen, otherwise we can move the slides from here.
I can share my screen. Hello.
Okay, perfect.
I assume that you can see the screen, right?
Yes, we can.
Okay, perfect. Then I can start. So good afternoon, everybody. I'm Katarina Valalaki from Hypertech Energy Labs, the project coordinator of Merlin project, and I'm here today to present you in a brief the Merlin solution from the different customers' perspective. This is the outline of the presentation today. Just to highlight that Merlin is an EU funded Horizon 2020 project that has developed an integrated local energy management system for optimal management of local distribution grid in scenarios with high penetration of renewable energy resources. The solution that we have developed in Merlin puts prosumers at the center while providing and creating a win-win situation, providing mutual benefits for all the members within a local energy community. Merlin's solution has been structured around the multi-level optimization approach. At the lower level, we have the building where the prosumer stands, and there we have a complete IoT solution that provides real-time data streams from various appliances within residential and commercial buildings, and all these are processed at this low-level optimization for providing a unique building flexibility that preserves user comfort and individual preferences. At the second level, we have the portfolio, a group of buildings that are managed by an aggregator. There we have a second optimization level where actually aggregator can optimize a group of buildings by taking into account the reliability of the users based on participation in past demand response sessions based on the cost of their flexibility and the adequacy of their resources in participating in specific demand response schemes. Finally, at the upper level, we have the distribution grid where the DSO stands, and then we have the holistic optimization framework that takes into account various district distributed energy resources combined with a large-scale battery energy storage system installed at the distribution grid level, while also takes into account the aggregated flexibility provided by the various virtual power plants and portfolios of the aggregators belonging to the specific local energy system. The holistic optimization framework presented has been designed in order to serve different business needs. Three of them can be seen here. First of all, through this optimization framework, we can support local distribution network management in order to alleviate thermal and voltage constraints in the local distribution grid, and this way we can support the economic operation and development of the local distribution network. Another business case that the framework can support is to provide security of supply, minimizing load shedding and inconvenience costs that frequently occur during emergency conditions. Just to mention that within Merlin, we have designed, purchased, and deployed two large-scale battery energy storage systems in our two pilot sites with grid-forming capabilities enabling the islanded operation. And finally, through this optimization framework, the solution can provide balancing and ancillary services while enabling the participation in wholesale energy markets. This, as you can imagine, can contribute to the reduction of energy cost within the local energy system consumers through, for example, the utilization of time-varying energy prices. In Merlin, the framework has been developed and deployed in 2 local energy communities, 2 pilot sites, the distribution grid of Enercoup in Crevillent, Spain, and the distribution grid of Energy Cushing at the area of Strem in Austria. As you can imagine, the holistic optimization framework presented targets 3 different types of customers. At the lower level, at the building level, as mentioned before, we have the prosumer. So apart from the complete IoT infrastructure with all the appropriate communication channels for providing real-time data streams for flexibility, context-aware flexibility calculations, we provide also a dedicated user-friendly UI where the prosumer can see the different insights as regards his consumption, production, flexibility, comfort, as well as we provide a dedicated view for participation of the prosumer in a marketplace in order for engaging in contract with various aggregators. Then we have the aggregator, just to mention that in Merlin, local energy communities assume either the role of aggregator, either the role of DSO. So here we empower local energy community, and apart from the holistic framework that is supported by the backend algorithmic framework, we provide dedicated UIs for the aggregator to be able to have a quick look on the consumption and production of its portfolio, the available resources, their adequacy to participate in the different demand response sessions. We also provide a dedicated view for aggregator to be able to check the IoT health of the equipment installed in the various prosumers. And finally, we of course have a dedicated view for the marketplace for the aggregator to search for prosumers and start a negotiation process for signing a contract with prosumers for participating in different demand-side management approaches. And finally, at the DSO level, we provide a number of views and UIs that, combined with the holistic optimization framework presented before, enable the DSO to have a complete view of the status of the battery energy storage system, to manage the on or off-grid operation, and provide statistics as regards the production and consumption of the local energy system, as well as different parameters are relevant to the operation of the local distribution grid. So that's all from my side as regards the Merlin solution from the different customer perspectives and the digital tools that we have structured to enable the energy transition.
Okay, thank you, Caterina. I don't know if there is any question from the audience or at home. So you can make question on the chat or for people attending online. So any question? Okay, so I leave the floor now to Tony Medved, which represent the compiled project. And please, Tony.
Hi, hello, welcome from my side. I'm Tomi Medved. I come from University of Ljubljana, and I'm here today to shortly present the compile project and to talk a little bit about the tools that we're developing and what we're doing in the project. So, it doesn't. Okay, sorry. Okay. While we wait for the next slide, let me tell you that we are in the third year of the project. We still have 1 year left, and more or less, I mean, we have all the pilot sites operational, and you can look here that we started in November 2018, and we're gonna finish in October next year. The thing is that we have, like I mentioned, we have 5 pilot locations, which will be presented, I mean, on the next slide. But and we are, if we can go just back a little bit, yeah, just a second. Can I? It's not working. Okay. Anyway, okay, just let's, yeah, because this is not okay. Okay. So the core of the project is basically the third bullet. If you look at it, if we have 5 pilot locations and we are developing, we call it compile toolbox, and compile toolbox is basically a set of tools that can enable full operation of energy communities in different settings. And like in news grids, we also have international cooperation, but we have it with India and China. But as we were discussing just before this, the start of the session, it's heavily impacted by the COVID, and I hope that this in the last year that we'll be able to carry out all the activities that were planned. Okay, so I think about what makes Compile a little bit special from all the other projects is that we have 5 pilot site locations, which are very different. They differ from organizational maturity, so from the total beginners to let's, for example, in Rafinha in Greece, where they just adopted their energy law, I mean energy community law at the start of the project, to Crevillent, which is one of the oldest energy cooperatives in Europe. And we also different from size, from a single multi-apartment building in Lisbon to a city in Crevillent. But then there's another dimension, which is where Compile stands out, is basically we have DSO driven, which is in Rafinha. So there's also municipality involved that they are thinking about the energy communities. We have cooperative driven communities in Križevci, Crevillent, and Lisbon. And in Slovenia, our main pilot site, in Luce, the energy community was basically supported and created by supplier. So suppliers saw an opportunity that energy communities are a way forward. Like I mentioned, our Compile toolbox is a set of tools that basically help you out from the start till from organizing the community to actually operate the community and manage the community. So if we start with creation tools, first of all, we have this, we call it a Compile Energy Community Toolkit, and you can check it also on our website. It's a vast collection of all the good practices, examples, and models how you can set up an energy community like in different countries. There's recommendations, examples, barriers, financing options. It's a comprehensive, let's say, toolkit with more than 120 pages. But we made an online version where you can simply, it's more user-friendly. You can simply click by a few questions. They guide you to the point where you would need to read and look for. So you don't have to go through the whole 120 pages. You have it on our Compile website. How to say, point and click, let's say, solution. And then back. Yeah. So then there is a Compile business model and value analysis tool. So more value analysis tool, which we are developing now. It's going to be web-based. We are going to deploy it in next month or 2. We're going to see. We already have the design and everything, but we did it for Slovenia, but we are now implementing the other countries. It's a simple tool where you can just check what is your potential for PV and, let's say, return on investment, so that it helps you out when you're thinking about, should I make the community or not. So those two, that's why we call those 2 tools creation tools. But then we have the technical tools, and these technical tools basically really help you out with the management and operation of the community. And we have the Compile Energy Community Cockpit, which is it's like a microgrid operator, which is used to control, let's say, community battery and house batteries, like the small portion of the grid. Then we have the Compile Building Energy Management System, and within this, we call it also HEMS, Home Energy Management System. The Compile partner Petrol developed this local control, which is innovative in that point, and that or in that view, that it allows the building, the PVs, to be controlled not on off when there's over voltage, but it goes with it changes the output of the PV based on the voltage, the network voltage situation. Let's put it that. So it as soon as the voltage of the network approaches the limit, it starts limiting, but it doesn't turn it off, but it slowly degrades towards the zero. This is important because with this kind of control, we really have the results, we have the measurements and everything, and we can show that we get 3 times more the output, and then if you would have 0, 1, because this was a very congested network where the DSO didn't allow us to install more than first 10, then they said, okay, maybe 35 kilowatt, but we installed 102 kilowatts. And we got the how to say, governmental from the agency exception that we can do that, and we showed with our control that we are able to safely run this community without any technical problems on the grid with our developed solutions. Then we have the EV management platform, which you probably know. Probably can imagine what it's doing. It's basically looking at when to charge, how to charge, and to try avoid simultaneous charging of all the cars in the village at the same time. We are developing this in addition. We further developing this in Xflex, and we just last week or 2 weeks now we had really testing with 9 electric cars. We gave them to the residents of the village, and they had it for 1 week. So we could actually see how, if they can, it's not just the simulation, but actually the testing with 9 cars there, people living and using them for their daily needs. And we saw how the network operates and what are the issues and what we can solve and improve. And then there is a virtual community platform, basically, that allows the management of the community. It's designed by ETRA, what this platform enables is that you can manage the community in a way that you can design to each user its own tariff, the price of electricity, etc., etc. It's in my opinion, it's a very complex tool, because a lot of people don't actually need this in that sense. But it's very useful if let's say a company like a supplier or somebody else would take it and design a new tariffs, and it could easily then apply it to the new energy communities in that sense. And basically this brings all together. I didn't put any screenshots on it because there's only 7 minutes here. But if you go on our website, you can actually see, you will see some animations. Not animations, also the demonstration movies for some tools, like screen recordings and explanation what they're doing. Also for the functionalities of HEMS, you will see animations, how this droop control is working and what else is enabled. And maybe as what we have achieved in our pilot site in Luce is probably for one of the rarest cases, I would say, in Europe, is where we actually can have an islanded mode in a network failure, because we have for that part of the grid, because we have 9 houses, that all have the PV. There's a few of them have the house batteries, and then we have the community battery, which is 150 kilowatt and 333 kilowatt hours. You can see the pictures and the movie on our website. And why it's unique, because this kind of islanding mode and this kind of battery in a low voltage network, it was never tested before in Slovenia. It was, again, regulatory exceptions, also a learning experience for DSO, because the DSO was, we don't have any procedure for that. And there was a lot of things, and to implement the battery. I was just talking before with a colleague here, and I said there were 59 steps to install and operate one battery. 59 steps, and the procedure took almost 1 year. So those are the things that are not that easy to implement but that's why these projects are here, to help us and to share the good experience and how to overcome those barriers and maybe shorten or lessen the steps to get there, in that sense. Okay. Question? Yeah?
You mentioned regulatory exceptions, and do you expect that in the following years, more regulatory exceptions will be granted to achieve based on the results you get? Or you think that the regulation will follow your limitation, let's say, what is your expectation, not the hopes?
Okay.
Can you repeat the question?
So the question was, what do we expect that these regulatory exceptions, or we call it regulatory sandboxes, will they, continue and be like even in larger numbers, or will the regulator finally accept our results and change the regulation, so there will be no need for this kind of regulatory sandbox? My question, my opinion, at least in Slovenia, it's like this, that agency does listen to us in that sense, but there is much more, let's say, high level political interest that things stay as they are, and they just give us the regulatory sandboxes. There are people that are pushing, especially the PV producers, PV installers. They're pushing into changing the regulation. Especially, for example, what we have shown is that you could install PV without any, let's say, without any allowance from the DSO, if you would install such a device that just takes care that you don't cause the problem in the network grid. And we would love to see that, because that would really open a market for all the guys who are doing the optimization behind the meter. So install whatever you want, just manage it so you don't cause problems to the grid. But at the current pace, in the current situation, there's no business that you can say I'm better because I'm better than that, or I can optimize it better than you, because the regulation itself tells you cannot install more than that and that and that, and then everybody go to the maximum because it's the most profitable. Are there any other solutions? There are, but will the government support it? At the moment, it's a process, and unfortunately, it takes years.
Okay, thanks, Tony. So now I leave the floor to the representative of Ielectrics. I don't know if Tanguy is going to present, or Pierre-Jacques. In any case, you can share your screen.
Okay, can you hear me?
Yes, we can.
Okay. So I will share the screen. My screen.
I need to choose the share screen, not share window.
Yes, you must share your screen, not share the windows.
Okay, I will authorize it.
Perfect.
Can you see my screen now? Okay.
Yes.
So Good afternoon, everybody. So my name is Pierre-Jacques Lecalec, and I'm the project coordinator of this European project called Ielectrics. So I will present you this project, and then I will leave the floor to my colleague to give you more information about special tools developed in one of these demonstration. So Ielectrics, we can say the main objective of this project, European project, is to accelerate, we can say, the integration of renewable energy sources into the distribution networks in a region where we can say that the network, the grid, distribution grid is weak, the so-called energy island. And the second main objective is to prepare also and facilitate the implementation of local energy communities. So you can understand that it is a DSO view of implementation of local energy communities. To do that, we have developed and implemented 5 demonstrations. There are 4 in Europe, in Germany, in Austria, and 2 in Hungary. And for this European demonstration, it concerns more, we can say, the medium voltage networks. And we have another special demonstration in India, in Delhi. And in this case, it concerns more the LV network. And it is, we can say that we have developed a urban microgrid able to work in an islanding mode. So all this demonstration implement battery energy storage system from 200 kV kilowatt up to 500 kilowatts. So we are now remain, we can say, 1 year. Out of the 5 demonstrations, 3 are in operation, and the 2 other will start very soon. And we'd like to present a tool dedicated, we can say, to digitalization of LV networks. So I will leave the floor to Tanguy Chonet from Audity.
Okay, thank you, Pierre-Jacques, for the introduction. So, hi everyone, good afternoon. So I'm Tanguy Chonet from Audity. I'm a project manager at Audity. So, how do you want to proceed, Pierre-Jacques? Do I take the lead on the screen, or no? Let's keep it like that.
Yeah, I can present.
Yeah, okay. So what do we do at Audity? So we work on the Indian demo site in the Ielectrics project. So the first thing that we do is that we collect data from smart meters that are already installed at customer level. And based on this data that we collect, we are able to build a digital twin that reproduces the network, the behavior of the network, and so with that, we don't need actually to collect any more information like cable types, cable length, network topology, or GIS information. And based on this digital twin, we are able to build business cases that will help the DSO run its microgrid. So next slide, please, Pierre-Jacques. Yes, thank you. So the first use case is the identification and analysis of the network, the low voltage network. So with this digital twin, we're able to find the topology of the grid. So we are able to say to which feeder, which phase, and which substation each meter is associated. We are also able to retrieve the sequencing of the meters and the electrical distances between meters. Next slide, please, Pierre-Jacques. Oh yes, just keep it like that. Yeah, I want also to point out that in the Ielectrics project, we have already done this first analysis, and we have found out that actually there is no overload found, that the substation is actually pretty well, let's say, the nominal power is sufficient, let's say. But we have found out that there are some imbalances between phases, and that high voltage excursions are very frequent, and that's due in a large part to a high production of PV. So next slide, please, Pierre-Jacques. Yes, thank you. And you can also click once again. Yes, perfect. So the second use case that we developed in this Ielectrics project based on the digital twin is an estimation of the capacity of the local network in terms of PV capacity. So with our tool, we are able to find the actually installed production, and also to have the precise analysis of the capacity per feeder, per meter, and per substation, while avoiding any reinforcement. So you can see on the right that there is an example of a map of available capacity. And we are also able to provide tools to rebalance the phase and optimize this capacity on the grid. So next slide, please, Pierre-Jacques. And you can click once again, I think. Yes, thank you. So the last business case that we developed thanks to this digital twin is the real-time state estimation of the grid. So we are able to find out what will be the state of the low voltage network 24 hours ahead. So for that, we need the digital twin that I already mentioned, but also we need more inputs like forecasted weather data and also HVMV substation data. So in the Ielectrics project, what we do is we built a demand response program in which we send flexibilities to the local DSO 24 hours ahead. So the local DSO is a Tata Power limited distribution. And we are also able in this program to continuously upgrade the program with a strong monitoring of customer engagement. What does that mean? It means that we are able to track if a customer did actually activate the flexibility that we sent before or not. And in that sense, we're able to say that if any flexibility is relevant or not. So that's how we do it. And yeah, I think that's it for me for this quick focus on the Odyssey activity within the Ielectrics project. So thank you for listening. And
Okay, thank you, Pierre-Jacques, and thank you, Tanguy. I don't know if there are any questions from the audience here. Yes, we have one question from Tommy. Yes, Tommy, you can yeah, yes.
Thank you for a very interesting presentation. I have a question regarding the digital twin. How many of the meters do you need to have it covered in the network that you can actually make a digital twin based just on the measurements? That's one of the things. What is the accuracy of the digital twin? Because if you don't have the network, I mean, the lines and everything modeled, that's another question. And the third question is basically, how do you actually do it based just on the measurements? Do you do the reverse engineering of power flows, or is there artificial intelligence model that you can kind of guess what kind of distances between them and what kind of line it is?
yeah, so
I mean, many questions, but yeah.
Okay, so the first question was regarding the how much data that we need to build a digital twin that is relevant. I would say that the more data that we get, the better it is. We are able to build a digital twin, I would say, based on maybe 2/3 of the meters that are on site, but the best is really to have 100% of these meters to have a relevant digital twin and to be precise, like you mentioned. The second question, I can't remember. It was regarding what? Can you repeat?
Yes,
It was
the second question was about accuracy.
So that's linked to actually how many meters what's the quality of the data that we get. But actually, we found out that if you have all the data of the grid, we are more precise that the actual tools that are used by the DSO, because these tools rely on data that is often not totally right, like cable length and phase association and everything. So we are able to build a more precise tool than what is actually existing. And the last question, can you repeat?
It's about, if I remember, yes, you did. How do you do that?
So it's based on artificial intelligence algorithms. So I would not be able to get into the details because that's not my my job, let's say. But it's based on machine learning algorithms.
Okay, so if you can come back to the presentation. Okay, we have completed the presentation of the 4 projects, and now we can start the panel discussion. So we have prepared some questions for the pilots, and I can show you. Yeah, okay, again. So let's start with the first question that is related to compile, so to Tommy and MuseGrids, to Alessandra, how to design technical and non-technical tools that can support the creation and acceleration of energy communities. So I leave the floor. I don't know who want to start. Maybe, okay. Ladies first, of course, Alessandra.
Okay, so from the experience that we had within MuseGrids on the design of the tool, and specifically on the planning tool, I would like to talk about it. The important aspect is to include the municipality, or actually the user of the tool, within its development. It's an important point I would like to say. So as engineering, or in general in research project, we usually develop things that are related only to the constraints and the needs of the pilots or of the users which are involved in the project. Actually, what we saw within MuseGrids and the development of planning tool, that to be able to be useful for a wide community and not only related to, for example, the municipality involved in the project, we need to design it through a participatory approach in a co-design way. So involving the stakeholders in the whole development of the tool. So starting from its scratch on the design. So how you are going to develop it during the development phase, during the testing phase, and during the actual implementation. So to continue to have a continuous feedback and exchange of idea, how the tool is set, what are results that you obtain from the tool, how the tools, which are the interface of the tool, and how to use it in order that could be actually useful for them. And it's important, not only in the design, but in a general point of view, to have workshop also where you present the tool and you use the tool actually together with the people that will use the tool in the future, to engage them, to inform them on the potentiality, how it works, and to collect feedback for its fine-tuning. So it's I would like to say a circular approach where the user, the stakeholder that are our client, I would like to say, so the one that will buy or use the tool after the project, because every tool at the end have the aim to be useful when the project will finish. So it's not related to the duration of the project, of course. So in order that the tool will have a marketability and it's useful for the user to involve them in the continuous in its duration, in its development during the project.
So now that Alessandra said it that well, I don't know what to add. But anyway, I totally agree, and our experience and the approach was similar as Alessandra explained. So it's user-centric and basically designed by the measures of the customers. Let's put it that way. What I would only add is that a lot of times what we see is that technical tools, and then they say, oh, we need the technical tools to be for energy communities, etc., etc. And I go like, okay, but do the energy communities really need these tools? Do they actually are interested in that? But you will find out that not all are engineers and not all are interested in that point. So basically, a lot of technical tools should not be developed, and that should not be developed, but for the end users, but more or less that they should be rather find somebody that knows how to operate it, that also has that has the knowledge to use the added value of the tools. Because the energy communities, the people that go to work and home, that then have families, etc., they don't actually care about how the the technical background is and how it works, etc. So in that sense, the companies that are going to use them, we need to be more involved with them, because we are basically creating solutions for the market, and the end consumer is not the one doing the market, the trading, and etc. So that's just my remark, what we saw, but we see it in a lot of projects that basically this is I don't know, probably it was due to because the commission said that you should create the tools for the end consumers. We are making them for the energy communities, but we also need to know that energy communities itself cannot be just operated by some tool without a guy who is managing everything. Either it should be supplier or somebody with a really interest in that. That's just my 5 points to that discussion.
Thanks, Tommy and Alessandra. And I think that is a very good point also, because we have to think that these two projects are starting now the demonstration phase. So they are at the end, they are beginning their last year of project. So they already have some insightful of what is the practical aspects of realizing local energy communities. Okay, we can go to the next question. That is mainly, so we thought, of course, we have another question from the audience for both. Two questions, sorry. I don't know, but maybe it's better if you want to come here to make the question, so also the people at home can answer.
Sorry, it was more of a comment rather than a question to the previous question. And I agree completely with both of you, especially with what Alexandra actually said about the idea, the need for co-creating the tools. However, what we find in our project at the moment, there's a big struggle between, we know there's a need for co-creation and we have some technical development going on, and realistically, the people that develop those tools do not have the time in the scope of the project or the kind of even background to accept that this co-creation process needs to work equally. And to be fair to them, it is a very complex process, designing a technical tool. And if you leave it open completely for interpretation to an audience that might not be, the experts in that way, it might be that, take it off for that. Yeah, so it might be a little bit more difficult to imagine how long that co-creation would take. So my kind of idea and question here is, there is actually a disciplinary gap between the people that develop those technical tools, the users that are obviously the communities, and then the people that, I don't know, maybe the researchers or social researchers that kind of engage in the co-creation process. How do we make sure that we kind of even that out? Because I find it personally very difficult practically. I know theoretically that it should be the idea. I wonder if you guys also have any kind of practical, empirical view of how that has worked within a scope of a project, especially a horizon project, that we don't have the endless time to do a very long co-creation process. So sorry, I don't know if that was too long.
Thanks for your comment, and I think that Alessandra wants to reply to.
Just the only thing that I can add on that is for sure some knowledge and experience on engagement of citizen. It's important within the co-creation process, and at the end you need to try to translate somehow the technical aspect that the technical person within the project and the technical words that the partners within the project usually use in a very simple words for the user, because most of the time they are not technical. And however, it's okay that it's a co-creation, but should be guided by somehow that have experience in tools, in this case in tools, and in engagement of citizen, and in creation of the tool. So someone that have, let's say, a wide experience and knowledge on all the spheres that are related to the development of the tool, and that can guide actually the user and the researcher and the tool developers. Because if there is no one that can facilitate the discussion, it takes very long time. If we have someone on that, let's say, experience and knowledge, it can facilitate the whole process.
Okay, so we have another question from the audience here in presence, but I want to stress that even if these questions are mainly addressed to these two projects, also speakers in virtual presence, so Pierre-Jacques, Tanguy, and Caterina can add their view if they want. Okay, we have another question here.
Yeah, it's kind of a similar question as to Ielectrics, but slightly different. And is it? Yeah, this is better. But it's often with these kinds of things, the devil is in the details. So maybe I'll ask it, and you can follow up a little bit. So it's a question about capacity. It's two questions, actually, two parts. One, I don't know, I think you were there yesterday when we were presenting our own efforts in this about co-creation, and starting with the principle that co-creation not only is about sort of helping to define the solution, but it's also about allowing the user to define what the problem is that needs to be solved. I was wondering whether there was the opportunity for the various users, the companies, the supplier in your case, I guess, and the municipality in your case, to actually help to shape how that problem was defined, and that kind of relates to your comment about like who is actually going to use the tool, because I could imagine that, for example, a municipality doesn't actually have the capacity, like the expertise to work with these very new type of technologies. And so if you would want to make most of their contributions or to the co-creation, would first have to kind of train them, whatever, in the material to get them kind of up to speed and understand how the problem could be defined and how it could be approached. Do you have any experience with these two questions of capacity? Thanks.
Tommy is going to reply to this question.
Okay, first of all, thank you for the question. It's like this, that in our case, the Luce, it was actually the local champion, we call it a local champion, who came to us and said, okay, we have a problem with network connection. First of all, there's a lot of outages due to the weak network, and a lot of, let's say, because it's a wooded area, there was a lot of trees falling on the lines and etc. And another thing was he wanted to install additional PV, and he was blocked by DSO. So the idea for the energy community came from him. You know, it was his, basically he came with the problem, and then the company came with the solution. So in that sense, we can say this was a perfect example of co-creation. You know, from the start, in that sense. I mean, I hope I solved the issue. I mean, that I answered the question. Yeah.
Okay. Thanks, Tommy. We can go to the next question that is mainly addressed to pilots to the project Merlin and Ielectric. So, what are the opportunities and impacts of digital technologies for energy communities? So, please, I think that we can start with the rule of ladies first. So, I don't know if Katerina wants to start. Jack and Tanguy can add.
Okay. I can take this opportunity and advantage from being a woman, if of course Pure Jack and Tanguy allows me. So indeed, the energy communities are facing changing regulatory and technological landscapes, both present opportunities and barriers as everything we have in front of us, the European Clean Energy Regulations that envisages important roles for energy communities and provides enabling conditions for their deployment. So the question is, what is for the digital technologies and the energy community? So from experience from the Merlin's project, but also for experience for other projects that we have been involved in, it seems that the energy communities can rely on digital technologies, taking, of course, into account all the points that discussed before by different colleagues in the previous question. So, for example, the ICT enabled coordination of different flexibility resources can maximize, for example, the integration of more renewable energy resources that could be a target of a local energy community. In turn, ICT technologies can, for example, through optimization frameworks, enhance self-consumption. That again could be an objective of an energy community. On the other hand, energy communities can also rely on digital technologies for sharing benefits. So we can imagine peer-to-peer exchange platforms or blockchains in order for establishing a fair, let's say, and transparent sharing of benefits among them. So I do think, based on experience from Merlin, that digital technologies provides the means and can support the development and operation of energy communities. Of course, taking into account the co-creation approach mentioned before, or, for example, on providing dedicated, simple and user-friendly views for the different tools for the targeted stakeholders to be able to use the technology as appropriate. So that's all from my side.
Okay, so maybe I can reply for Ielectrics. So digital technology for me, it's a key enabler to integrate renewable generation of energy communities in the global power system, we can say. And also, I would say this digital technology can improve efficiency and quality of local power supply when the grid is not so reliable. So I think about, for example, in India, with this microgrid able to work in a islanding mode when the MV power supply is not available. And maybe also there are some drawback, we can say, or negative impact with this introduction of digital technology. There is introduction of cyber security risk. So this is something that we have to take seriously into account in the development of this solution, digital solution. So I don't know, Tanguy, if you want to add something. Or...
Yeah, thank you. Yeah, I think you globally answered the question. I also wanted to mention, but I think Tommy did it also previously, regarding the impact of digital technologies. I think that not everyone is ready for implementing digital technologies in the energy system. Especially the end users that are not always let's say engaged in this kind of process because they don't have the knowledge and they don't have the direct benefits of it. So I think this point is important. And yes, I also wanted to mention that in the Ielectric project, we try to also assess this issue with a strong customer engagement with a specialized, let's say, a company, Gecko Global, that works on this topic. So that's how we try to assess this negative impact or risk, let's say. And yes, for the rest, I agree with what was previously said.
Okay, thank you. So we have only 10, 12 minutes left. So I'd say that we can discuss about the last question. Then we will see if we have time. This is last question is mainly addressed to all the projects and is this one. So are there some regulatory barriers to development of new technical and non-technical tools? So I think that in some of the presentation, this question has been slightly addressed, but I would like to have an insight from all the coordinators and all the projects. So we start maybe from yes, we can start from virtual presenters. Okay, Caterina, I don't know if you want to start, please. You can switch on your camera if you, so we can.
Sure. Okay. So as regards the barriers from let's put it in different views. I would like to focus on DSO and aggregator view that also explored in Merlin project. So from the DSO point of view, a barrier is the lack of complete definition of local energy communities. So a single and comprehensive and consistent legal definition is still missing. Another thing that we would like to highlight is as regards the islanding operation that is explored in Merlin and Ielectrics, as colleagues from the project presented before, is that DSOs are frequently reluctant to allow islanded operation due to concerns for stability and controllability, while there is a lack of data around supply valuation and inconvenience costs experienced by consumers in emergency conditions. Furthermore, for the DSO again point of view, we have concluded that there is an unstable regulatory framework and some processes are really complex and create bureaucratic procedures that delay the permission granting and creates also additional costs and risks for energy communities. Further, basically, in the case that, for example, local energy community is going to participate in a business model, assuming, for example, the role of DSO managing the local distribution grid. From the aggregator point of view, barriers that we have identified is that as regards the participation in energy trading, for example, we constantly see in various members from for the various countries in EU that there are constant in time flat retail tariffs. While local energy trading is forbidden by regulator or the DSO. On the other hand, for example, for participation in balancing servicing, there are some restrictive constraints that prohibit the participation of various stakeholders in such markets, like, for example, the minimum size of bids. So these are some key barriers at legislative, let's say, barriers that we have identified in Merlin, and I think that apply also in various countries around the EU.
Okay, thank you, Caterina. I don't know if Pierre-Jacques and Tanguy.
Okay, so concerning these regulatory barriers, we have also identified, what Caterina was mentioning, and I will add also something linked to the implementation of the battery energy storage system, which is not an easy task, whatever the European country, and also the transposition of the clean energy package regarding energy communities differ from the different member states, and this is also inconvenience for energy communities because it differ from country to country. So this, for me, are the two main drawback on the, we can say, from the regulation obstacles. So Tanguy, if you want to add something.
No, I agree with what you said, and that's the point of view of the DSO. Personally, I don't have it. I'm more focused on my activity from ODT from a developer company point of view. For us, the buyer is more about accessing to the right data. It's our main challenge in this kind of project. Yeah.
Okay. Thank you. I leave the floor to Alessandra here.
Okay, so what can I say related to the experience of MuseGrid? And again, I'm talking about the planning tool for the municipality. Actually, it's a planning tool, so you are going to just simulate different scenarios that are related to your municipality, so you don't have in the simulation phase regulatory barriers to be faced, because you can simulate everything you want. Of course, the main barriers are more related when, of course, you are going to implement the technologies that you have considered in your energy scenario on the field. And actually, the planning tool and what could be a benefit and advantages is that with the planning tool, you can simulate and understand different scenario, and to understand if specific barriers that could be on the regulatory framework related to a particular scenario that could be, I don't know, the vehicle to grid aspect, it can make sense to, let's say, create regulatory sandbox or push to have regulatory framework, because you see from the planning tool if that scenario is have an important impact on the grid, on the system, on the municipality, and okay, if it's an important impact on the system, okay, you say, I can push it, I can push the regulatory, I can push the policy to make some, let's say, regulatory sandbox or modify the regulatory framework for that. Otherwise, if you don't see the impact from the simulation of the scenario, maybe you can try to understand other possibility, other, let's say, other solution to be implemented in your system. So actually, from the regulatory point of view, the main ones in the development of the tool, you don't have regulatory barriers, but these are mainly related to the future implementation of what you have simulated. Sorry, no, I was just to say that we have some problem on.
Okay, yes, here in presence we have some problem because we cannot see you from the screen. Okay, and so Tommy, I don't know, you are the last one.
I'll be quick. If I may. Yeah, like Alessandra mentioned, there are no, basically when you're developing things, there are no regulatory barriers. The only thing regarding the technical barriers, what we could see and what we saw was the data privacy. So when you're developing things in sense of management tools for the energy communities, and etc., you need to take into account also this anonymization part. That's one thing. Then the second thing is basically what we saw more is, I mean, the regulatory barriers are just mostly related then to the implementation. For example, you can develop a trading platform, you can develop peer-to-peer trading, you can develop whatever sort of services, etc. But if you don't have the actual market for it, if you don't, if you cannot deploy it, then you can consider this as a regulatory barrier. And in addition to that, especially to for example, to some new business models. For example, in Slovenia, the energy communities could not be formed with using virtual metering points from the PVs that are in this called yearly net metering mode. So we need to change. We need to wait for a few more months for new legislation to be passed to officially apply to create the energy community. Otherwise, you would need to have a separate certified meter on each of the PV to include them into these energy communities. So there are barriers, of course. I would say the most of the barriers are in multi-apartment buildings due to the connection to the laws with how the multi-apartment buildings are managed, so that you need to have from 75, at least in Slovenia, from 70% to 100% approval rate from all the people living in the building. So imagine that if you have 100 people or 100 apartments or even 50 or even 20. So that's quite an issue, and this needs to be changed as soon as possible if we want to push anything regarding energy communities in the multi-apartment buildings. That's all from my side.
Okay, just few words to close this session. First of all, I thanks all the presenters, both here in presence and virtual presenters. And of course, the way through the local energy communities started, but as we can have seen since yesterday and with the session of yesterday and today, we are working on it. And of course, these projects, as the others, can provide some solution and some insight for future development. So I think that the most important thing that we have demonstrated with this project and we are demonstrating in this project is that local energy communities are a viable solution, and we can do that under the technical point of view, but some other issues, barriers can be still addressed. But the aim of this project is also to provide not other tools, but also feedback for regulatory frameworks in order to overcome this kind of barriers. Okay, I thank you all again. I close this section, and I thanks also to the attendance in the virtual conferences. Thank you, and follow the other section starting at 4:30 p.m. Right now. Sorry. Right now, sorry. Okay.
Okay, so thank you. Thank you, everyone.
Thank you very
for your
much.
attention.